The law of cosines. We can use the law of cosines to help us find and solve triangles. Now, we just looked at solving a triangle given two sides and an included angle. And now we can also use and would use the law of cosines if we are given three sides, side, side, side. Now, the first step that we want to do in terms of finding or using the law of cosines is we want to find the angle measure that is going to be the largest. Now, how would we know to do that? Well, we should know that the largest angle is going to be opposite the largest side. So it's never a bad idea just to sketch a triangle just for fun, and it doesn't have to be drawn to scale. You're just trying to get a visualization. So let's see, we got a triangle here, ABC, and we're told that side A is 5, so that's opposite angle 5. So this side is 5, and side B is 11, and side C is 8. And of course, 11 is the largest side. So let's find angle B first. And we're going to use the law of cosines. And so we're going to take 11 squared, side B, equals side A squared, 5 squared, plus side C squared, 8 squared, minus 2, negative 2, times A, 5, times C, 8, times the cosine of B. Now, when we get to the end of this calculation, we're actually going to find the inverse, use the cosine inverse to find the angle measure. So let's see, 11 squared is 121, equals 5 squared, which is 25, plus 8 squared, which is 64, negative 2 times 5 is 10 times 8, that's going to be negative 80, cosine B. And let's add the 25 and the 64 together. So we got 121 equals 989. Yep, 89 minus 80, cosine B. And let's subtract 89 from 121. Subtracting 89 both sides, and when we do, that's going to end up being 32. So now we got 32 equals negative 80 cosine B. We're going to divide both sides of this equation by negative 80, and so we come down here to negative 32 over 80 equals cosine of B. And what we want to do is find the inverse, so we're going to find the inverse of this to get the angle measure. Now, hopefully everyone knows how to find that inverse on your calculator. If not, we'll take another look at that at class. And we're going to round the angle measures to the nearest tenth. And when I put negative 32 over 80 into the inverse of cosine function on my calculator, I'm going to have an angle measure that 113.6 equals angle B. Now we use that largest, we find the measure of the largest angle first to make sure that the other two angles are going to be acute, so that we can now solve for angle A and C using the law of sines, which is a little bit easier calculation. So let's see, why don't we find then, well, let's find angle A. And we're going to use the law of sines. So I've got the sine of 113.6 over 11. That's sine of angle B over side B. And that equals the sine of A over 5. And let's see. And so we're going to then have 5, multiply both sides by 5. So we got 5, the sine of 113.6 over 11 equals the sine of A. And just like what we did with to find angle B, we're going to take the inverse of this, 5 sine of 113.6 over 11. And once we do, rounding to the nearest tenth, we find that angle A is 24.6. Now we're going to take the sine of angle B and side B along with use it again to find angle C. So now to find angle C, let's see, there's angle A. There's an angle B using the law of cosine. So we got a little room here in the middle. Let's find angle C. So I got the sine of B, angle B, which is 113.6 we discovered, over 11, equals the sine of C over side C, which is 8. So then we get 8 sine 113.6 over 11. Again, we're going to use the inverse sine function to find angle C, and rounding to the nearest tenth, we got 41.8 equals angle C. So then we can cap this off by saying that A is equal to 24.6, B is equal to 113.6, and C is equal to 41.8. All right, there we go. Solving a triangle, beginning using the law of cosines for the largest angle, which we're going to identify by solving for the angle that has the largest, the greatest length side opposite it. And then once we get that angle, then we can use the law of sines to finish off and find the other two angles.